there's also going to be one this way. I don't know if we really want to give it a name. This is going to be the friction, maybe. I'll call it today. Okay, friction. F of x is Now I hear somebody say, I don't know if we're doing friction. I'm not doing like there's a coordination of friction of 0.22 and all that sort of stuff. What I am doing though, if this box is at rest, you have to show an opposite force to gravity. That's what I'm saying here, okay? Right, that's the idea. Okay, so then the next thing that I'm going to get here, and I'm going to sort of zoom in a little bit here if I can. Oh, good as that. The next thing I'm going to do is I'm going to add 2 more forces in here. Okay, and I'm going to zoom in here to sort of show what I did there. Okay, if you need me to zoom in. This is, guys, can you hold on for a sec, please? 196.2 is the force straight down. Then I'm going to put 2 more forces in here. I'm going to call this FGY. I'm going to call that FGX. So this is going to be the force. This is going to go down the ramp. This is going to be the force perpendicular to the ramp. Okay? And again, you guys will notice this. If you ever walked on a hill, you'll notice again you're forcing yourself downwards based on how steep the hill is, right? Or if you rode a bike, right? If you're biking up a steep hill, it's really hard to get up that hill. If you're biking down the hill, there'll be a force going with you. I'm talking to physics people. You guys all know this, right? There's nothing new here. Yes? Now, the tricky part that always gets me is, where do we put that 15 degrees in? Where's the 15 degrees going to go? FGX? Okay, the reason that happens here is I'm going to draw a big triangle like this. That's going to be a right angle. I showed that backwards, Joe. I think this is 15 up there. Let's say 15 was up there. That's the way it is. I'm saying that's 15 degrees there. That's what I'm saying. Okay, so let's look the way I did this. The way I did this was using a similar triangle. I consider this to be. Okay, there's that. So what I did is there's the ramp. There's FGY, and I have that heading over there. It's going to be a right angle. So then what I did was I said, well, this is 75. If that's a right angle, that makes that top angle 15. Okay. So then I made another, so that's a that right there. Please think deeply, because this is another mistake that P has made for people here. Okay. Please be brave and ask. We'll do a lot of these. This is all we're doing the rest of the same plane problems. Okay. Today, so we're getting more difficult ones tomorrow. Okay. So the reason that's 15, right, is again, if you continue this triangle here, make that a right angle. Okay. This part's going to be 75, making this part up there 15. That's what I'm saying for that. Okay. Do I need more diagrams here?
Should we say a force of friction opposes the direction of attempted motion? Because if there's a force applied up, then the force of friction will be going down.
Yeah. We'll leave. Yes, I'll leave that for right now, though. So I'm more worried about the trait here for right now. Okay. Okay, on where that's coming from. Please be brave if you're not, because this is the only confusing part of this. Yes. Okay. Good. Let's solve for FG and Y and FGX. Okay, so this is another components question if you take a look. So I'm going to say FGX is equal to 196.2 sine 15. Can somebody calculate that for me, please? How much, sorry? 50.78. What's the direction of this? Down the ramp? I hope somebody said it. Okay, down the ramp. Okay, so this force is actually heading down the ramp. I hope you guys have all your pictures together. If that falls well, this is too easy for you. I just want to make sure it's good. Okay, good. Here we go. So then I'm going to do here FGY is going to be the same thing. So it's going to be 196.2 cos 15. FGY is going to be what then? 5.1. And this is going to be, how am I going to say this? Perpendicular down. Yeah, how am I going to describe that? Is that fair to say? Does that make sense what I'm saying here? Like it's perpendicular, but instead of going like not perpendicular to the hill would be this way, so it's perpendicular into the air. That's what I'm trying to say. Well, it is, all right, into the hill, perpendicular into the hill. Okay, so this force is heading downwards into the hill. How you doing? On the yes, this is good, makes sense? Yeah, so this is, and again, so this is always f of n. We said it's going to be negative FGY. Right, that's what always happens there. Okay, so because that's perpendicular downwards, right, the normal force will be upwards. And again, that's assuming there's no motion, right? Like if you're walking on a roof and you're walking up the roof and there's no problem then, all of a sudden if the roof breaks because there's too much force, then of course your acceleration goes downwards because there's no normal, right? But that's the idea, right? As long as you're not falling, there is no normal force. We're good? There is no force. So far so good? Time to crank it up to 11? This is all coming back. You guys done this in physics this year? Yeah?
Yeah.
You have, so this is all straightforward. Good? Okay, let me know if I make a mistake. So I'm doing physics this year. I'm just joking. I don't make mistakes. Except for on textbook questions, apparently. Example 4. That's it. That's all we're looking for was this. That's all we're looking for. All right, so example 4. Okay, an 80 kilogram sled is resting on a frictionless hill. Inclined at an angle of 12 degrees. If the arm of the sled is angled 30 degrees to the hill, A, draw a free body diagram, and B, calculate calculate the force that must be applied to keep the sled in equilibrium. And then calculate the normal force. Why is this question a slight bit more awesome than the previous example? What's more awesome about this one than the last one? Somebody say nothing, okay? But this is calculus, every question is awesome. Not you, because I know you know. No one else knows the power of this question. Why is this one more awesome than the previous example? You guys are writing. I'll fix the friction. No friction is okay. That's not the thing. Something with that arm is the problem. Okay, that's the definite problem with this question. Okay, so if you think the way you pull on something, I will always make up these questions. I don't have a dog anymore. It's a very sad story what happened. I don't want to get into it right now because I will cry. Okay, but I used to walk my dog on a frictionless hill, which would be my sidewalk covered with ice. Okay, and he would pull me. Okay, but what I noticed when I walked my dog was if I'm trying to put a force on my dog to get him to stop, okay, right? It's not going to be horizontal, right? What happens when you're walking your dog? You're going to be angled down like this, right? So the force that I'm applying isn't going to be opposite gravity. It's going to be upwards this way, right? So this question is similar to that. When you're pulling the sled on the hill, you're not pulling the sled horizontal. You're actually lifting, you know what I mean? You're pulling upwards. If I'm walking my daughter on the sled, I'm not pulling it, I'm pulling the force upwards in this direction, okay? So I'd like you to try and get the free body diagram, okay? The force applied, remember, is going to be 30 degrees to the hill, okay, which would be cool too, okay? We'll do the free body diagram. I'll give you a second to try your free body diagram, and then I will take up the free body diagram, okay? Try and do it. Do your best. Start with gravity if you don't know where to start, okay? Start with FGY, FGX, FN, the force of gravity down the hill. Yes. Oh, sorry. What I mean is by that is, I'm thinking of my own sled, so it's like, there's like, my sled that I had my kids is something like this. It's like a wagon. It's like, these I have a sled that actually in the summer it's a wagon, in the winter it's a sled. Like I take the wheels off it. That's really what it is. Okay, so that's the worst. Not original. Okay, so.
Can I go get a drink?
Yes. Okay, so take a second, try this one out. Okay, so draw